So in the previous class we have discussed about mean deviation. So we have already learned how to calculate mean deviation for ungrouped data and for also continuous series. So under this ungrouped data, we will discuss about mean deviation from arithmetic mean and again mean deviation from median. So today, so that is for ungrouped data, and even for continuous distribution we have mean deviation from mean and then mean deviation from median that we have calculated. So today we are going to discuss about the calculation of standard deviation for ungrouped data. Yesterday it was mean deviation, so today it is standard deviation. So under this standard deviation, we are first going to talk about the ungrouped data, and even here we have ungrouped data and then continuous series. So under this ungrouped data standard deviation, we have actually four methods. That is actual mean method, and then assume mean method, direct method, and step deviation method. So let us see them one by one. So first up we have standard deviation for the actual mean method. Let us try to calculate the actual mean method for ungrouped data standard deviation for actual mean method. So formula for actual mean method is given as it is here. So actual mean method equals to square root of the summation of the d square divided by n. So first step which is included for calculating standard deviation is, so this is the question given here. We have to calculate the standard deviation of the following values. So first you find out the mean x bar. First thing you have to find out under actual mean method is first find out x bar. So x bar is nothing but summation of the given values divided by the number of observations, and what you get is 120 divided by 5. So x bar is 24. So next step is you form a table like this. So x is the values or data of the question, and you have to find out d square here, summation d square. So to find out d square, first you need to find out d. And how do we find out the values of d? D is nothing but x minus x bar. So x is this one, and we have found out that x bar is 24. So 5 minus 24 is minus 19. 10 minus 24 is minus 14. 25 minus 24 is 1 plus 1. 30 minus 24 is plus 6. 50 minus 24 is plus 26. So that is how we get the value of d. D is nothing but x minus x bar. X bar we have found out that it is 24 and x is this one. So you minus these values with the x bar and we get d. D square is nothing but you square this. 19 square is 361. 14 square is 196. 1 square is 1. 6 square is 36. 26 square is 676. And now we have summation d square, that is 1270. Now you substitute the values of this. So here we can write summation d square as summation x minus x bar square, because this d square is nothing but summation of x minus x bar square. That is why we are rewriting this formula. So we have found out that summation d square is 1270. Number of observations n is 5, and when you divide this you have square root of 254, and square root of 254 is nothing but 15.937. So that is how you calculate the standard deviation under actual mean method. Formula is this one. So second, let us try to calculate for standard deviation under assume mean method for ungrouped data. So the next method is assume mean method. So calculation of standard deviation for ungrouped data for assume mean method. So we will try to use the same values that is given or that we have calculated for actual mean method. We will use the same values. So for the same values, deviations, that is D, can be calculated, from any arbitrary value. There is any arbitrary value ax bar. So assume that is any arbitrary number that you can take, such that now D would be equal to x minus ax bar. So earlier for actual mean method D, you can find out the value of D by x minus x bar. So earlier it was like this, but under this assume mean method, we can find out the deviation, that is D, by taking any arbitrary number, that is a. So now D, as I have mentioned, will be now equal to x bar. So deviation can be found out like this under assume mean method. That is the only difference. So we will try to use the same values, and now here taking a x bar equals to 25. Now we will assume that a x bar equals to 25, and the computation of the standard deviation is shown below. Let us try to calculate. Taking a x bar equal to 25. So 25 is our arbitrary number. Let us try to calculate it by using the same values that we have calculated before. So for assume mean method, the formula is given like this. So square root of summation d squared divided by n minus summation d divided by n whole square. So that is the formula for standard deviation for assume mean method for ungrouped data. So you need to find out summation d square and summation d. N is number of observations. Number of observations is 1, 2, 3, 4, 5. So summation d square, you need to find out d. So as I have said, d can be found out by, x minus ax bar. So here we are assuming that our ax bar is 25. So we find out the value of d by x minus ax bar. So 5 minus 25 is minus 20. So how we got d, or how we got minus 25 minus ax bar is 25. So we have minus 20, and 10 minus 25 is minus 15. 25 minus 25 is 0. 25 minus 30 is plus 5. 50 minus 25, 30 minus 25, and 30 minus 25 is plus 5, and then 50 minus 25 is plus 25. So summation d would be minus 5. So 30, and then this is 35. So minus 5 summation d. D square is square of 20 is 400, square of 15 is 225, square of 0 is 0, square of 5 is 25, square of 25 is 625, and we get summation d square. So you just substitute all these values in the formula, and summation d square is 1275 divided by 5 minus summation d is minus 5 divided by n is 5 square, and what you will get is some square root of 254, and square root of 254 is 15.937. So that is for standard deviation under assume mean method for ungrouped data. So the third method is direct method, and the fourth would be step deviation method. So thirdly, we will discuss direct method for standard deviation for ungrouped data. So for direct method, standard deviation can also be calculated from the values directly without taking deviation. So without finding any deviation, you can calculate the standard deviation from the values given below as it is. So x is given from the question. We are using the same values, and so from x you can find out the x square. So we are taking directly from the values given without taking any deviation. So the formula for direct method is this one, summation x square divided by n minus x bar square. So you find out what is x bar and find out what is summation x square. So x square is 5 square is 25, 10 square is 100, 25 square is 625, 30 square is 900, 50 square is 2500. So summation x square, you sum up all this and you get 4150. How to find out x bar? You sum up all this divided by number of observations and found out that x bar is 24. Summation x square is 4150. So substitute these values in the formula. So summation x square is 4150 divided by number of observation is 5 minus x bar is 24, so 24 square. So when you do the calculation, you get square root of 254, which is equal to 15.937, with the same with the earlier answer when you calculate the actual mean method and also the assumed mean method. The last method under standard deviation for ungrouped data is step deviation method. So the last method under standard deviation for ungrouped data is step deviation method. So we are using the same values here again. So if the values given here are divisible or by a common factor, if they can be divided by a common factor, they can be divided and standard deviation can be calculated from the following values. So when you look at this, they have a common factor that is divisible for all, that is 5. So you find out x dash. So x dash is what? X dash is x by common factor. So 5 ones are 4, and then 10 divided by 5 is 2. So 5 5s are 25, 5 6 are 30, 5 10. So that is how you get x dash. You divide the x values by the common factor and you get x dash. So how do you get the deviation, the step deviation d dash? So here please be careful. D dash is nothing but, please make a correction in your book. So in your book it is given x dash, but d dash is x dash minus x bar. So you have to find out x bar. X bar is, you sum up all this divided by number of observations. So 24 by 5 equals to 4.8, that is x bar. So d dash, the step deviation, can be found out by finding the difference between x dash minus x bar. So x dash here is 1 minus x bar is, as we have said, it is 4.8, which is equal to minus 3.8. And then 2 minus 4.8 will be minus 2.8. And then 5 minus 4.8 would be plus 0.2. And again 6 minus 4.8 would be plus 1.2. And 10 minus 4.8 would be plus 5.2. So now you can find out summation d dash, and you will find out that 5 6, this summation d dash will be 0. Now what is d square? D square is this one. 3.8 square is how much? It would be, I think, 14.44. 2.8 square is 7.84. 0.2 square is 1.44. 1.2 square is 1.44. And then 5.2 square is 27.04. And summation d square now is 50.80. So you substitute this formula is given here, summation d dash square. So here it is d dash, summation d dash square by n into c, and here summation d dash square, we have found out that it is 50.80 divided by number of observation is 5, common factor is 5, and when you calculate that, you will find that it is square root of 10.16 into 5. Therefore, square root of 10.16 into 5 would be again 15.937, which is same with the previous method that we have used. We have used different method, but the answer we get is the same. So that is it for the standard deviation for ungrouped data. So we have calculated 4 methods. Next is for continuous series. So standard deviation for continuous series. Let us see, there are 3 methods.